So after we have understood all the methods from analytics vidya, which I have just explained you up, now it's the time to convert into this format which is in front of you, right? So this is the format we would like to convert. Now you would notice this is very simply done by this two line of code. So we're gonna use this count vectorizer to get this done for us. But there will be a problem. We can't really use this much of amount of tax what we do have. So we need basically some better method to solve this. So one way is, let's say, basically I have a set C, right? So let's say I have a set C which contains some data. So for this, let's say I have a question one which contains the tag T1, T2, T3, and I have a question Q2 which contains the tag T4, T5, T6, right? Now, let's say these are my tags. Now, what I would do, so if I look at my set C, this is going to be T1, T2, T3, T4, T5, and T6. These are my tag sets which we're gonna have. Now, in this case, what we will do, we will, instead of taking this set, we will choose a different subset, which is going to be a subset of this C, C dash, a subset of C. So let's say by some strategy we have chosen that we're gonna take T1 and T2. And we will do that actually with the help of frequency count. Like the more the higher frequency, we would like to retain it. Otherwise, we would not like to retain it. So we will choose like that. So in that case, how this conversion is going to happen here? So in that case, Q1 will be left with maybe T1, T2, T3 will be removed from here. And Q2 question, if I talk about, this will become null because there's nothing left with it. So as I said, what we will do, maybe out of these tags, because we already have the sorted frequency of this, so maybe we can decide that we will go only with these two. But while doing this, we have noticed that we will lose few questions, because when I lose this question, I have to remove this question now, right? I don't have any tag left for it. So we would like to minimize it as well. And we will see in Python how we can basically achieve this kind of scenario. So what we can do is we can look at the tags what we want to choose here. So this is a simple code to do that, because I need to take a sample of my tags. And this is the question explain part which I've done. So let me explain you what basically this is gonna do for me. So in order to achieve this, let me show you up. So this is the graph which we wanted to basically get. That's the reason we have basically written all these functions. So if you look at this, there's a mistake here. Actually, this should be percentage of question converted partially, and this is going to be number of tag. So if we look at this, this tells me that if I choose 500 tags, okay, top 500 tags, I will be able to cover 90% of my questions. And if I choose, let's say somewhere around basically 5,500, then in that case, it will cover almost like 99% of the question, right? This is 99% and this is 90%. Definitely 99% looks better for now, because we will lose only 1% of the question if we just reduce the tag. And if you look at it, definitely it is better than having 40k, because 40k is a huge number if I compare with 5,500, right? But we will try this, but let me tell you, the computationally it will be very expensive, and it may happen that we may not be able to use this well. If it's gonna happen, we can always fall back to 500, where we will lose 10% of the question, but we will be okay with it because we can go ahead with it. If you have a high computation system, very high computation system, feel free to use all the tags also. But then you will end up creating 42,000 model, remember, which we learned in the last previous lecture. So you have to choose wisely that what you want to go for. So 99% seems to be a safe choice, going with 5,500 models. And let's see that how this gonna behave. So what we're gonna do, so as we have seen that with 5,500, we will be retaining 99.04% of question. Now, number of questions which are not covered means what are those 10% of questions which will be like 9,599. Now, if I look at the basically number of tags in the sample, this is going to be basically 35,422. And basically this is remember earlier it was pretty huge. Now it is reduced up to a good limit. And number of tags what we have taken is 5,500, which is almost like 15% of my original one. Right? That's what we have basically chosen. Now, one interesting thing to note here, while I have to do the split of train and test, actually, if you were a software engineer in Stack Overflow, the best idea would have been if I have a timestamp with me, because if you're working basically in Stack Overflow company, you would also have the data with the timestamp. Right now, Facebook have not given us, but definitely with Stack Overflow, this data will be there. So when I'm going to do this train test splitting, it will be a good idea to do it time based. Maybe the some part here will be a train initial time and the latest part will be a test. This will make more sense. Why? Because think about it. Maybe I have yesterday some language like ASP 1.0. Today ASP.NET 2.0 is released. So questions will start happening for 2.0. So let's say earlier it was iPhone, some older version. Now a new version came up. So the questions will also come up for the new version. So a new tag will be created for it. So in Stack Overflow, the tags will keep on getting generated dynamically for us. So in that case, it would have made more sense to use temporal kind of splitting rather than doing a random split. But since Facebook have not provided us the timestamp, we will simply go with our random split, which is 80-20 split we are going to take up. So you can see that we are taking this much of records in my train set, and this is my number of columns we have. You can see that it's just 5,500. This is the number of tags what we have chosen in this case. Now let's go ahead and look at the how we're gonna visualize our data. Now in order to do this, what we're gonna do, so the first step is we are going to compute the TDIF vectorizer for this. So basically again we need to apply all this data, right? And we are taking the maximum feature as 20,000. But one thing to note here is we are going to also and this TDIF we are doing it on question and all that. Okay, this is done on questions part. So here in this case, we are choosing the n-gram as 1 and 2 and 3. Only 3 and n-grams what we are choosing in this case. Now we are going to convert it to vectorizer, and after that this in fact was a huge data in itself, and it took me almost like 9.5 means almost around 10 minutes that I've taken to do that. Now, when we did that, means when we applied this TDIF on basically on my question set, now definitely my number of columns are going to increase. So you can see that in the basically this part in the X portion, we got 88,244 columns because now we have applied the TDIF on that. Then similar, but this is my input rows. Input rows will remain same. There's not going to be any change. On the Y part, it will remain as 5,500 column because we have chosen that many number of labels in the last case. But number of rows will remain same as it is, right? So that's what is you can see in these four cases. Now, what we are going to do next. So this is interesting. What we had done was that analytics with their thing, which I have just shown you in the last lecture, I tried to use after that basically this multi-class. And what basically the problem happened was, so this SK multi-learn we used, and then I end up with some memory errors. Okay, so I kept on trying to figure out that what went wrong because looks like it was pretty decent. So this was the memory error I was getting. So it was a decent one. So I was not able to get what exactly is going wrong in this case. So then I went over some stock exchange and basically learned from there that this issue is being faced by a lot of people. And this issue happens because this data what you have, input data what you have is very sparse. And this SK multi-learn is only good to work with respect to dense data. It is not good with respect to your basically sparse data. And that's the reason you are ending up with this memoria because it will work with respect to so many columns, right? It have to create so many models and all that. So we have very high chance that you will end up with basically the memory error. Even if you have a huge computation system, you can still end up with such sort of errors because if you go to this post, you will read a lot of people who have mentioned that even they have a very high processing power, it still didn't work for them. So then what we can do with this, so we just commented out this code, but I've shown you the code so that if you want to use, you can use it. But at the same time, we what even this community have said that they're going to fix it in the latest version, and they have not done it at least by the time I'm recording this video. So we cannot just stop this case study. So we will use our own method, which we have basically came up with to basically solve this problem in that case. But yes, if this method was available and working without this bug, then it would have been a better method to use here. So maybe in future, at the time when you are viewing this video, maybe this error is fixed out. So you might want to just kind of uncomment this code and see if this works for you. If yes, then comment out my later code, and then you can use this and see that a better performance coming up. In fact, it will be good. You can just post it on the discussion forum, and I would love to again change it back. So that is something which I can do it.